All right, let's do a quick little video on a couple of things. We'll do the first one on instantaneous rate of change. We've done this in activities by looking at a table or a graph and seeing what seems to be going on near this, although this is instantaneous rate of change, so we're going to think of that a little bit differently. We've got a projectile on another planet, and we want to know how fast it's moving at the instant that it has been moving for 2 seconds. Okay? And the idea here is we've got an inverted parabola. The 2 seconds is maybe in, I don't know exactly where it's going to be, but what we had done before was we would take the value here at 2, and then we would try to creep values in that were closer to that, and watch the pattern as we got very, very close, and look at this tangent line here, whose slope, because this has units here probably of time measured in seconds here, and maybe this is height measured in meters, and so the slope is going to have units of meters per second, which is a speed. Okay, the approach that we're going to take is to look at this gap between these points. So we have this point that we're going to choose here, some random x, and this other one is at 2. We know we want that one, and we can talk about there being a gap of a certain size, and we'll call that size h. Okay, so x we can also refer to as 2 minus h, and then the point up here, we're using the one point at 2 comma whatever h of 2 is. We'll figure that out. And we have a point at 2 minus h, comma h of 2 minus h. Okay, maybe we should have used an f instead of an h, but that's okay. H of 2 minus, try that all again, 2 minus h, comma h of 2 minus h. Is the one point. The other point I could have figured out ahead of time, but I didn't. Is 2 comma, let's see, we got 80 or 20 minus 16 is 4 plus 5, 2 comma 9, I believe is on that point, or on that graph. No, 40 minus 16, not 9. 40 minus 16 is 24 plus 5, 29. So 2 comma 29 is the other point on the graph. So we want the slope between those 2 points. Slope is change in y over change in x, or in this case the change in height over the change in time. My one height is 29 minus what I get if I put 2 minus h into this equation up here, okay, which is going to give me a negative 4. I'm going to scoot this all down here a little bit. I'm going to run out of space. Negative 4 times 2 minus h squared plus 20 times 2 minus h plus 5. Okay, so this is the first height that we had in the blue. Okay, so that's this 29, and this other one is the h of 2 minus h. We'll have a little simplifying to do there. Okay, and that's divided by the difference in time, which is 2 minus h. Okay, this is going to be my approximate rate of change. My instantaneous rate of change is what I would get if this value of h went to nothing. Okay, so the idea there then is that I want the limit as h goes to nothing of this 29 minus negative 4 times 2 minus h squared plus 20 times 2 minus h plus 5 all over, well, 2 minus 2 is 0 minus negative h. That just becomes an h, so that bottom simplified very nicely. Let's move along and keep working here. will be the limit as h goes to 0. I want to keep that in mind, that I'm trying to squeeze that gap between these 2 points down to nothing. So I'm going to have a 29 here, minus, and inside here that's a negative 4. 2 minus h squared is 4 minus 4h plus h squared, plus 40 minus 20h plus 5 over h. Colors again just because I can. Still waiting for an opportunity. I mean, that, I guess in trying to evaluate the limit, I know that the first thing to do is to just try to plug the 0 in, but what happens if I plug the 0 in? If I did from the very beginning, obviously the denominator is going to 0, and I'm going to find that the numerator also would go to 0. Okay, which is some indication to me that something should be able to cancel out along the way here. So I'm going to keep going. 29 minus, and now this is going to be a negative 16 plus 16h minus 4h squared plus 40 minus 20h plus 5 all over h. Okay. Haven't read yet. Limit as h goes to 0 of 29. Now some things may start happening here. I could combine some things in here. I've got a minus 16 of 40. That's 24 plus 5. That's 29. So I've got a minus 29. The h's, I've got a 16h minus 20h. That's minus 4h's, but minus 4h's is plus 4h's and a plus 4h squared. And that is all over h. And then I notice that I've got 29 minus 29, well that's 0, but everything that's left in the numerator up here has an h in it. In fact, it has a 4h in it, so I can factor a 4h out, and that'd leave me a 1 plus h over h, and h divided by h cancels. That simplifies, and now my problem looks like the limit as h goes to 0 of 4 times 1 plus h, which now doesn't have a division by 0 problem. This is just 4 times 1, which is 4. And that should be the instantaneous rate of change of this projectile at 2 seconds. It's moving 4 meters per second at that point. And that's the change in height over change in time. Okay. This is one approach to that problem. Hopefully it kind of makes sense. Watch it over a couple of times. Make note of anything that didn't make sense. Like I said, there are other ways to do this, but for now I am going to shut this video down, and then I'll make another one for another purpose.